So you all have been working on your adventure games for a couple weeks now, and you're probably getting to the point where you have a lot of code and you're struggling with how to actually organize it well. So how can you organize it in a maintainable way, a way that's easy to understand? And that's what I want to demo for you today, is one possible way that you can structure your game. And we're going to pick up with the paint drying demo that we made when we learned how to create a keyboard controlled menu. So this was a simple game where there was like a credit screen, and if you play the game, you choose a color, and then it prints out that color for you. And the way that we did this was we had a game class. It had a main menu method, and from that, after we ran the menu, we went to one of three different methods based on what the player chose. And so if you took this forward and our game had a bunch of different choices, this game class would start to become massive. We'd have methods for each choice, and that would make for just like an incomprehensible file that would take forever to debug. And so I want to show you an example of what we're going to build, and then we can talk about the structure. So same deal with loading title screen. Then when we play the game, we get some text about we have to go paint our room. That's our task. And we can go try and explore the garage. We can't see anything. There's nothing to do here. Let's go back, check out our room. Got some options for exploring our room. Try and paint the wall. We don't have any paint, so we can't paint the wall yet. So what if we look under the desk? We got a flashlight, which, the garage was dark, so let's go back to the garage. Now we can get into the garage, pick our favorite color paint, head back to our room, paint the room. Haha. So we are going to learn how to create this structure, but this structure involved many choices, right? So if we were to try and build this game out using this current structure, this game class would become really large and hard to deal with. So I'm going to close this down, and I have a .NET project set up here, and I'm going to kind of go through this pretty quickly since we've stepped through building some of these parts before, and do some copy and pasting so that we don't have to spend a while watching me type. But what we're going to do is bring in system.console, and we want to set up a couple of things. Like we want to change the title in here. And then I know ahead of time that I'm going to be doing this navigation system where the player uses their arrow keys to select menu items, and so I don't want the cursor to be visible. And then I want to try setting the window size to a specific size that I know ahead of time my game has been designed for. So I want to use these dimensions, and then we can print out a message here. If we weren't able to create a console window of the appropriate size, we can get rid of this. And let's create a couple of classes while we're at it. So we're going to need a game class since that's what we had last time. And we're also going to add a console utils class this time. So there are a couple of things that we do often in the game that we have done often in games in general. And so one of those is waiting for a key to be pressed. So I'm just going to throw that into this. Let's make this a static class. And static means that we don't have to instantiate it to be able to run static methods or access static fields. So here I'm copying in a wait for key press method that just prints out this text and then waits for a key to be pressed. And I'm also going to bring in a method in here that we can use when we need to quit the game, since there'll be a couple of places in our flow where we'll let the player quit the game. So this is just a shared set of methods, and if we wanted to add some more for like formatting and changing color, we could put them in here. which would mean that we could use them in any class. So for instance, I can come back to program and I can say console utils wait for key press. So this will just make it so that after we try and set the window, if it didn't work, we'll display this message and wait for a key to be pressed before we kick off the game. So let's get something running. Inside of our game, we'll have a constructor and a public start method. And this, let's just put some placeholder text in here. The game is starting, and then we can have console utils dot wait for key press. So all I've done is just some boilerplate. We should be able to create a game over here and then call the start method to kick things off. This should resize the window, print out some message if that the console settings don't allow us to get a 130 by 35 window, and then our game kicks off and just prints out some text here. Game is starting, press any key to continue, and that's pretty much it. So now that we got some boilerplate, let's play that final version of the game again here. So this is what we want to build, where we have this title screen, and then we can go explore the garage or the room, and if we go to the room, there's choices and things to explore here. And the key to realize with this structure is, we could try and jam all of this into our game class, but there are pieces of this that are really not connected to one another. For instance, our title screen and this code here that runs for the room, there's no reason for those to be in the same class. We can just separate those out, make them independent classes that we can run when we need to, which will then make it easier for us to look at the code for either of those. There's less distracting things. So we'll have a class that just manages the title screen. And then anytime we need to adjust the title screen, we just go to that class. And same thing we'll have a separate one for the room. And anytime we want to change the room logic, we go to that room class, as opposed to having all of these things in one file. So what we're going to build, if you have heard of programming patterns before, is called the state pattern, or it's at least something related to the state pattern. And if you don't know what that means, don't worry about it. You'll hear about that at some point in your programming career here at Columbia. But what I want to do is create a bunch of classes for each of those things that are in our game. So we're going to have a title screen, and let's call that like the title scene. And we're going to have like a navigation scene and a room scene and a garage scene and a credits scene. So each of these can be its own independent class that manages its own logic. So the credits scene is just responsible for displaying the credits and then asking the player if they want to play again. The title screen is just responsible for displaying the title and then giving the player the option to play, see some about info about the game, or exit the game. And similarly, like the room scene, that's just responsible for the logic that happens when we are inside of the room. So what we're going to do is create this base class of a scene that then all of these inherit from. And we're going to make sure that our scene has like a run method, so that when we have our title scene, we can say title scene.run. That'll kick off the logic for the title scene. Since our room will also inherit from scene, we'll be able to say room scene.run and kick off the logic for the room. And so then once we've put the logic into these separate classes, it's just a matter of telling the appropriate scene to run at the correct time in our game to create the flow of going from the title screen through all of the places in our world that the player can explore. So let's create, since we're going to be creating a bunch of classes that are all related, I like to use folders to start to organize my related code. So if I right click over here on my solution, I can click add new folder. I'm going to call this scenes. And now when I go to add an item, I can actually add it to the scenes folder here. So I could right click, add class, and let's create a scene. And let's also add a title scene. So inside of our scene class, one thing that you'll notice is when you create your classes inside of folders in C#, it's going to use a different namespace here. It's going to use the name of your project, dot scenes. And if we look back at our class, this is just the name of our project. So when it comes time to bring this class or the title scene class into our game, we're going to have to be aware of that, and we're going to have to bring in that namespace. So let's build out our base class and then our title scene class. And then we'll start to see how this scene structure works. So what I want to do, I want to create a constructor here, and I'm going to want to create a public run method. So this is going to be the thing that, you know, runs the actual scene logic, and we want to override this in child classes. So what we want to do is we'll mark this as virtual, which means that we could then override it in our subclasses. And then one thing that we want to think about is, you know, what do all of our scenes need? And we'll get into this. This will start to become more clear when we start hooking up multiple scenes together. But for now, what I want all scenes to have is access to the game class. So we're going to create a couple fields up here, like the player and the title scene, the navigation scene, basically all of these are going to be fields up here. And by making sure that the scene has a reference to our game, we can access any of those pieces of information. So in our room scene, we'll be able to access our player and manipulate its inventory or check whether it has, you know, the paint in its inventory. So for now, what we'll do is protected game, my game. When we create a scene, we will say that you have to pass in a reference to the game, and then we can store that in the field. And we're making this protected, which means that any of the subclasses can access it. So that's our base scene, and it'll start to make a little bit more sense when we fill out our title scene. So let's flip over to our title scene and say that this inherits from our scene, which means that we have access to this field and we have the ability to override this run method. So let's do that. We are going to need to create a constructor here that takes in a game, and we are just going to say that this should call the base, the parent class's constructor, and we can actually just leave this blank. We don't need to do anything in our title scene constructor. And then we want to make sure that we override that run method, and let's just say title scene is running and console utils dot wait for key press. And if we flip back to our game, what we can do is create a field here for our title scene. So I'm going to say that this is public title scene, my title scene. And this is going to complain to us to say that title scene, it doesn't know what that is. It doesn't exist in the current namespace. And so remember that our title scene here was in scene structure demo.scenes, and our namespace here is scene structure demo. And so if we want to be able to use title scene here, we would have to say .scenes.title scene, or instead we could say up here using and bring in that namespace from that was created for our folder. So I've got my title scene here. we can instantiate it and say, here's a new title scene. And it wants a reference to the game. So we want to give it a reference to this game that is being instantiated here, which is a little tricky. It's like, well, how do I get access to that variable from inside of my game class? And actually, there is a keyword, this, which refers to the current instance when you're inside of one of these methods. So if we're inside of the constructor here or we're inside of start, this actually refers to our game instance. So we can just pass in our game to the title scene. So we've instantiated our title scene, and then instead of saying the game is starting, we can say my title scene.run. If we go ahead and run this, we should hopefully see title scene is running. Press any key to continue. Can get rid of this too. So the real value of this structure is that we can now put all of our title scene logic just in this class, and all we have to do is say run to kick off the title scene, and that's completely separate from any other scenes that we want to create in our game. So maybe for demo purposes, you know what? For demo purposes, I'm going to pause the video here. I'm going to fill out the title scene from the past paint demo that we created, and I'm going to fill out a credits scene, and then we'll take a look at it. Okay, so I added a couple of things. One, I added the menu that we created in the paint drying past video, which is controlled by the keyboard, so go see that if you want a refresher on how to build that. And then I added a credits scene here, which inherits from scene. It has a run method, and all it does is print out some credits and then ask the player, do you want to play again? Yes or no? And this, we'll fill this out together, restart the game. And this should be console utils.quit console. Then inside the title scene, I pasted in our title art. I have it create a menu that has, like welcome, play, about, exit, and then if they choose play, we should run the game. I just have some placeholder text for that because we'll fill this out together. There's the about info that gets printed out, and then there's also the quit console that runs the exit command basically. So inside of program or inside of game, I have an instance of my title scene, my credits scene. I instantiate them. I run the constructor here inside of when the game constructor is run. And then inside of start, we can choose which scene we want to run. So right now it's running my title scene. So if I hit play, we end up in the title scene. We can, get the about info. We can hit play with our placeholder text there. But I could also just hop into my credits scene and test out that logic separate from our title scene. So I can see, yep, this is working. It's printing out the credits. It's asking me if I want to play again. I can hit no, press any key to exit. So we've got this structure where we have the logic completely separated for the title scene and the credits scene, which means that if we need to change something about one of those, there's only one file that we really need to go change. Like if I need to adjust the credits, I go to the credits scene file. If I need to adjust the title, I go to the title file. So like maybe I want to get rid of this text. I know that that's in the title scene file, which really helps simplify your logic when you're working on bigger projects, because if all of these pieces of logic are in the same file, it's really hard to track down bugs. So let's fill out some of those placeholder pieces of information, which will help explain why we did this, where we made sure that every scene via our base class here was constructed with a reference to the game. So when we're in our title scene, we want here to be able to go to a different scene. We want to kick the logic over and say the title scene's done. Run the garage scene or run the room scene. In this case, we'll make it jump to the credits scene, which will help show the flow, and then I'll pause the video and fill out some of the other scenes so you can see how it works with a bunch of scenes together. So here, what we want to do is be able to access our instance of, say, our credits scene and say run. Our title scene doesn't have that as a field. We don't have access to the credit scene, and that credit scene lives inside of our game class. So what we kind of want to be able to do is from the title scene be able to reach up here and grab the credit scene and tell it to run. So let's start the game in the title scene, and inside of our title scene, instead of this placeholder text, we can access that my game field that we created in the base class here. So my game. And then if we say dot, we can see all of the public fields and properties and methods that the game has. So we can actually see, oh, there's the credit scene. So that's what I want. And I want to call run to kick the logic over to the credit scene. And then in the credit scene, when we want to restart the game, we can do the same thing. So let's get rid of this and do my game dot start. So when the player says yes to would you like to play again, we can reach into that field, which refers to our game instance, and just call start again so that we kick off the title scene running. So now we can see that flow hooked up together. So we've said that if the player chooses play, go to the credit scene. And then from here, if they want to play again, we call run again. And so we're back here. And we can cycle through these pages, and the logic is nice and tidy, separated in two separate files. So if we take this forward, what we can do is structure each scene in our game separately, and then it's just a matter of when we have those menus displayed and we give the player an option and they're going to transition from one scene to the other, we just reach to the game and grab the appropriate scene and call the play method on it. So let's build out a couple of things that we'll need here. So this game structure works where there's a player, they have to collect a flashlight to go into the garage, to go get the paint, to go paint their wall. So we're gonna need a player class. So I'm gonna add a player here. This player, I'm just gonna paste it in to speed things up. So what we have is a couple of properties here. We have a has flashlight property, which is a Boolean. It has a getter and a setter, which means that other classes will be able to say player.hasFlashlight to read the value, or player.hasFlashlight equals true to set the value. We have a similar property here, hasPaint, which anyone can read, but only the player class can set, and paint color, which is a console color that anyone can read, but only the player can set. So we have a constructor here that says hasPaint is false, hasFlashlight is false, and then we have one method here which is public, so other classes will be able to call this, which says pick up paint. And you pass in what color, it now flips the Boolean to say that the player has the paint and stores that color. So we're going to use these. When the player's exploring, they're going to have to find the flashlight. So we're going to be able to flip this to true when they've picked up the flashlight. And when they pick up paint, we want to both flip this to true to say that they have the paint and also store the paint color here. So we can go back to, we can save this, go back to game, add in that player. And what I'm doing here is making this public, which means that we'll be able to access it from within any of our scenes. So my player equals new player. I have constructed the player. And if we just test this out, if I go to the title scene and just start typing in my game dot my player dot, we'll be able to see, oh, there's the has flashlight, has paint, and paint color, and pick up paint. All of the things that are public we can access from inside of our title scene, which will be important when we actually have things that manipulate the player's inventory and the player's status. So starting to build this out a bit more, I want to add another class here, and this will be the navigation scene. It is going to inherit from scene, which means that it's going to need that constructor. Whoops. That takes in the game. And that override run method. And I'm going to pause the video for a second to fill this out. So I just pasted in a quick menu here that tells the player they've got the exciting responsibility of painting their room. Do they want to go to the garage or go to their room? And if they select the garage, we have a little to-do that gets printed out that the player should move there. And if they go to the room, a similar thing. And let's also add console utils.wait for key press here. Wait for key press here. So we will fill this in a minute, but we're going to have to create the garage class and the room class before we can actually hook up the logic here. But at least we can go back, now that we have another scene defined, our navigation scene, we can go back to our game, create the navigation scene, instantiate it. Whoops, this should not have my there. So now, instead of having the title scene go to our credit scene directly, we can instead have the title scene go to our navigation scene. So I'm going to go to the title scene class here to run, and instead of saying my credit scene.run, I'm going to say my navigation scene.run. If I hit play, should be able to go from here, play, to this scene where it's telling the player that they can go to the garage or room, and we haven't filled these out yet, so it's just going to print out a to-do note, and then the game's going to be over. So we should fill out those classes, and I think I'll pause the video while I fill those out, and all of this code will be on Canvas, so you can always download it and walk through it a little bit more slowly. So pausing the video, be right back. Okay, so I added a garage scene and a room scene. We'll dig into those in a second, but I'm going to hook them up into my game. So we can get rid of this comment because now we actually have all of the code in place. So I'm going to create a new garage scene and create a new room scene. And I'm going to go into my navigation scene, and instead of having this to-do note here, I can actually call into my garage scene and tell it to run, and do the same thing here, my game.myRoomScene.run. So let's see it running, and then we'll dig into some of the code. So we can go explore the garage. If we try and go there without the flashlight, it tells us we can't see anything. There's nothing to do here yet. We can go to the room. We see our ASCII art here. There are a couple of things to explore. We could try painting the wall, but we don't have the paint. We could try looking under the desk. There's a flashlight. Take it with me. If we try and look under the desk another time, it prints out that it's empty because we've already taken that paint. So we could go someplace else. We can go to the garage. We can pick our color of paint. Then we can go back to the room and we can paint the wall. And beautiful, we're done. We did it. Game over. So it takes us to the credits scene, which allows us to possibly restart the game or quit out. So let's quit out. And let's actually look at what the code looks like for the room and garage scene. So I think let's start with the simpler one. So the garage scene. With each of these scenes, we could create fields that are unique to the subclass. So the garage scene has a garage art field, which stores some of the ASCII art. which has a couple shelves with some paint and a window. We could have put this into a text file, and I'll leave that as a challenge to you to improve your code. You can always store your ASCII art in a text file, read it in, so that you don't have all of the ASCII art cluttering up your code. But you could have other things here, like if we wanted to have other things that the player can interact with about the garage, like we could have a Boolean is window open. And now that piece of information is stored in the garage scene. We can read it to determine, like whether or not the player can like see out the window, see some clue out the window if it's open, or they could go over and interact with it, open it, close it. So you can create multiple fields, whatever you need for each scene can be tied up in that scene as a field. And then you don't have to have a whole bunch of variables in your game for all of the pieces of information. You can put the pieces of information that are relevant to the scene as a field inside of the scene. So with that out of the way, let's look down at the run method. So the run method here has to do a conditional check, right? Because if the player tries to go into the garage, but they don't have the flashlight, we're not letting them explore this area yet. So what we can do is reach into the game, and because my player is a public field, we can see if they have the flashlight. So if they don't have the flashlight, then we can go ahead and print this message out about you can't get in here yet, and we can kick them over to the main navigation. If they do have the flashlight, then we can print this out where we tell them that there are 3 options, red, green, blue. And what we can do if they choose the red paint is call that pickup paint method that we created inside of player here, where we pass in a color, which then says that the player has paint and stores the color so that we can refer to it later. Same thing for green paint, same thing for blue paint. And then when this finishes, we can kick them back over to the navigation scene since they've finished up with what they can do in the garage anyway. So one of the things that we're seeing here is that for pieces of information that we want to sort of like share across scenes, we can do that through, for instance here, the player. So we have some information, some state that the player holds onto, whether it has the flashlight and paint. And as long as we make sure that inside of our game, we have added our player as a public field, any of our scenes will be able to reach into that player. So we're able in the garage scene to manipulate what paint the player has, which then we can use in the room scene to actually paint the wall. So we've been able to separate out our logic into these separate scenes, and then the pieces of information that get shared across the scenes, as long as we make them public fields of our game, we can access them from it within the individual scenes. So let's take a quick look at the room scene as well. Same structure. We got this old school computer, desk, 2 windows in our ASCII art here, and our run method prints out a menu of options. So go someplace else, look under the desk, paint the wall. If they go someplace else, that kicks us over to the main navigation. If they look under the desk, then we can go to this method that is interact with desk, and we can go to this method, interact with wall, if they actually choose to paint the wall. So let's look at the interact with desk. Oh, and these are public, but there's no reason for them to be public, so I'm just going to change them to private while we're here. So the interact with desk method, so the player's chosen to go over to the desk and look at it, we can check our has flashlight. So if the player doesn't have the flashlight, then, oh, well, we'll let them know that the flashlight's there, they're picking it up, and we can flip the player's has flashlight field or property to true. And if they already have the flashlight, we can print out that it's empty because the player's already taken that from this scene. We can wait for a key to be pressed, and then what we can do is call the run method to kick us back to this option. So after they look at the desk, they'll be able to go someplace else, look under the desk again, or paint the wall. If we look at the interact with the wall, we can check, does the player have the paint? So if they don't have the paint, then we can print out a message, you can't paint yet, and we can kick them back up to the run method and let them choose like inspecting the desk or going someplace else. But if they do have the paint, so inside of this else, what we can do is print out the room again, but print it out in the color that the player has picked from the garage. And then when all this is done, we can kick them over to the credit scene. Okay, so I ran through that really quickly. I will make sure this code is in the canvas so that you can download it and play with it yourself and step through it line by line. The real advantages here, we've separated out our logic for each of the scenes by using this base scene and then having each scene override the run method. We've got this common interface for how we can run our scenes. So any other scene that we want to run, we can just, grab it from the game, call the run method to kick our logic over to that scene. Not only does this make it easier for us to sort of structure our game so that we don't have just a game file with thousands and thousands of lines of code all jammed together, but it also means that because we have separated out this logic, we can go into our game class, and as we're working on adding new scenes, like say I was working on the room scene, I hadn't finished it yet, but I wanted to test it. And the structure that we have set up here, you have to go to your title scene, then the navigation scene before you can get to the room scene. But as I'm testing, I can just grab this room scene, call the run method, and run it. And immediately as I'm running my code, I'm in the room scene, and I can start tweaking this. And then I can, close it, change some code inside of our room scene. Like maybe, we wanted to say, here's your room. The wall is looking pretty blank and boring. And to test what that looks like, we would just hit play. And because we've set things up to go directly to the room scene, we can see that change immediately, as opposed to having to click through the main menu, to the navigation, to the room. So not only does this structure help you with organizing your code, but it also gives you some nice advantages for as you're working, you can test independent parts of your code quickly and jump straight into them. I'm going to change this back to my title scene. So the funkiest part of this structure is probably this, since this refers to whatever instance the method is attached to. So we've got our constructor here. So when we say this, that actually refers to an instance of the game, which means that from our title scene, we have access to anything that we create that's public inside of our game. This isn't the best way to structure a game. Normally you want to kind of restrict access a little bit more than we're doing here. But for Intro to Programming, this is enough of a structure to help us organize our code in a way that's a little bit easier to maintain and a little bit easier to work with. As you continue to learn new concepts in programming, you'll learn new ways that you could have organized this in the future. Like you may learn about singleton patterns in game programming soon. You may learn about the state pattern. You may learn about locator patterns. Like there are all these patterns that will be helpful later on, but this is at least enough of a structure to get going in Intro to Programming. So spend some time with this, download it, run through it, see if you understand it, see if you can apply this to your own Choose Your Own Adventure game. Good luck.